Good day to you. My name is Teacher Mendy. I'm going to take you through solving quadratic inequalities. We want to solve quadratic inequalities. So before you solve the quadratic inequality, you have to know what is a quadratic expression. What is a quadratic expression? A quadratic expression is in the form ax is in the form ax squared plus bx plus c is equal to 0. So this one is a quadratic, it's a quadratic expression. So we want to solve quadratic inequalities. So if this one is a quadratic expression, you must know the cases where a is the coefficient of x squared. There are two cases that you should know. If a, the coefficient of x squared, is greater than 0, let's say a is a positive number. This is a quadratic function. Why? Because the highest power of x is 2. So if the coefficient of x squared is greater than 0, the graph is minimum. The graph will be minimum, where it will cut the x-axis at two distinct points. And if a, this coefficient, if a is less than 0, then the quadratic graph is a maximum. It's a maximum graph. So these are the two crucial points that you need to take note. If you are given a quadratic inequality or quadratic expression, make sure you are able to identify whether your function is a maximum or a minimum by identifying the coefficient of x squared. So we want to do this example. So they're saying if the coefficient of x squared is positive, the curve is minimum shaped, like what I've said. If the coefficient of x squared is negative, then the curve is the maximum shaped. So let's look at this example, the first example. We want to solve this inequality. Let me write on a whiteboard. We want to solve, we are given x squared minus 3x minus 4 x squared. We want to solve x squared minus 3x minus 4 is greater or equal to 0. Minus 4 is greater or equal to 0. So this is our quadratic inequality. This is our quadratic inequality. So the next step you need to do is to find the critical values. You find the critical values. You find the critical values, or before you find the critical value, you can factorize this expression. I think you are now able to factorize this expression. Let's factorize before we find the critical values greater or equal to 0. Here we have x squared. X squared is as a result of saying x times x. Here we have minus 3x, then here minus 3x is our sum, then 4 is the product. So if you factorize, you are going to get x plus 1, x minus 4. Get x plus 1, then x minus 4. We've managed to factorize. So after this stage, this is our function. We are solving our function f of x. We can say this is our function f of x. Or like we are saying, we are solving our f of x being greater or equal to 0. Being greater or equal to 0. Being greater or equal to 0. So the next step, we need to find the critical values. So find critical values. So we find critical values. And how do we find the critical values? We find critical values by solving f of x equals to 0. By solving f of x equals to 0. So already we've factorized this one. So we are going to take this equal to 0 and this equals to 0. So to find the critical value, we convert x plus 1, we equate it to 0. So if we equate x plus 1 equals to 0, we are going to get x is equals to minus 1. We are going to get x is equals to minus 1. In the second bracket, x minus 4, we are going to equate to 0. X minus 4 is equals to 0. We are going to get x is equals to 4. So these are the two critical values that we have. X equals to minus 1 and x is equals to 4. So the next step we are going to sketch the diagram. Since the diagram, as you can see, the expression, the coefficient of x squared is 1, which is positive. So our graph is a U-shaped. It has a minimum because the coefficient of x squared is it's 1, which is greater than. So here the minimum value of x is minus 1, and here we have 4, right? And we are solving a function f of x. The graph that I have drawn is the function f of x. It's greater or equal to 0 here. Our graph, we want to find the region where our f of x is greater or equal to 0. So as you can see, this region, the one I'm shading, this region is greater or equal to, our function is above that horizontal line. So the function is greater or equal to 0 if the graph exists above the horizontal line. So the region that I'm shading satisfies the inequality. It's greater or equal to 0. So this region is for x greater or equal to 4. If we are given greater or equal to, make sure you are substituting greater or equal to. But if it is less than or greater than, we just put also here x is less than minus 1, x less or equal to minus 1. So these are the two regions. So our solution, how do we write our solution? So our solution, we combine the two. So for their solution, we combine the two. So our solution is x less or equal to minus 1 union, we're going to combine union x greater or equal to 4. So this one is our solution. So if you are given a quadratic inequality like this, if you can factorize, you can factorize. So after factorizing, you identify that you are solving for greater than or equal to 0 or less or equal to. Then the next step, you find the critical values. How do you find the critical values? You solve the equation f of x equals to 0. Then, like if it is in factorization form, you just equate the two brackets to 0. Then you get x equals to minus 1 and x is equals to 4. Then after that, you go to a number line and indicate that your function is minimum. Since the coefficient of x squared is 1, it's greater than 0. So your graph is minimum. So you have minus 1 and 4. Then we are going to shade the region which is greater or equal to 0, or the region which is above the horizontal line. This is the region which is above the horizontal line. It's for x less than -1 and x greater than 4, greater or equal to 4. So the solution will be x less or equal to -1 union x greater or equal to 4. So that will be the same answer with this one. So moving on to the next example, we want to look at another. Right, so for our next example, we want to look at this example where we are solving a quadratic inequality, but in this case, it's a different scenario. We have this inequality: 6 plus x minus x squared is greater than 0. So the next step, if you can factorize this, we can factorize this. Like this 6 is coming from multiplying 3 and 2, we get 6. Then if we multiply negative x with the x, you get this negative x. Then if you say 3x minus 2x, you get x. So after factorizing this quadratic expression, you get this one. This one is in factorization form, so it's greater than 0. So after this, you have to see whether you are solving, which direction are you solving. We are solving for the function f of x greater than 0. So it is a region which is above the horizontal line that we were drawing. Then after that, you have to find the critical values by equating all the brackets to 0. So if you equate this bracket to 0, you are going to get your x equals to 3. And if you equate this bracket to 0, you are going to get x is equals to -2. So these are the critical values. Then we go to the graph. This is our horizontal line. We have -2 and 3. And since the coefficient of x squared is -1, we said if the coefficient of x squared is negative, the graph will be a maximum. So it will be a maximum passing through -2 and what, and 3. So this is the graph. So we want to find the region where this function is greater than 0, means say the region where the function is above the what, the line. So the graph is above the line from -2 to 3. This graph is above the line from -2 to 3. This graph is above the line for -2 and -3. So this is the region which is required. So our solution will be saying x is between. So if x is between two values, it will be in this form: x is between -2, the lower limit, and 3, the upper limit. This will be our solution. This will be our solution. This is going to be our solution. So when solving the quadratic, you have to factorize. If you fail to factorize, you can use quadratic formula to find the critical values. But you have to identify whether your function is a minimum or a maximum. So you have to draw your function on the line, the horizontal line, and the horizontal line, it simply indicates if the graph is above the line, we are solving for f of x greater than 0. If it is below, we'll be solving for less than. So if it was less than, the region for that, it's x greater than 3 or x less than -2 if we were solving for f of x less than. But in this case, we are solving for greater than. Our solution will be -2 less than x less than -3. So this is our solution. This is our solution. Right. So for your task for today, sometimes it will be easier if we are given the function in factorization form. It will be easier. As you can see on number 1a, the function is already factorized for you. So the next step you need to do is to just find your critical values. Then after finding your critical values, you have to see if the graph is a maximum or a minimum. Like in this case, if you remove brackets by multiplying x and x, you're going to get a positive coefficient for x squared. So this will be a minimum graph and will be solving for less or equal to. So your exercise today, I want you to do, let me tick, right? You do number 1D, number 1F, and number 2. For number 2, you do number 2D, 2H, and 2L. And number 3, you do number 3A. For number 3, you have to take everything to one side. Is the hint. Take everything to one side. It will be x squared minus 2x minus 35 is greater than 0. Then after that, you factorize or you find your critical values. So number 3A and number 3I. So this is your work you have to do to it today. So thank you. We are going to see in the next lesson which concept are we going to